Hi students, good afternoon. Today I am continuing the lesson gravitation, and in the lesson gravitation, today I am explaining a concept of an object under free fall. Yesterday I have explained you about the Newton's universal law of gravitation, and today in the Newton's universal law of gravitation we have understood about the gravitational constant capital G, and in today's class I am explaining about an object under free fall. See, an object. This concept mainly concerns about an object which is under free fall from a certain height onto the ground. So that it is influenced by the acceleration due to gravity. Acceleration due to gravity, and this is denoted by small letter g. This is denoted by small letter g. Now, in the today's class, I am explaining how to derive the expression for small g. And in my study class, I have derived the expression f is equal to g m by d square. And here in this formula, f is force, g is gravitational constant, m is the mass of the earth, and m is the mass of the object, and d square is the distance between the earth and whatever the object. And here, according to Newton's second law of motion, according to Newton's second law, we know that f is equal to ma. Here m is the mass of the object and a is the acceleration. Here in place of the a, I will substitute m into z. This is acceleration due to gravitational force of the earth. The same I will substitute here. In place of the f, I will substitute mg. M into g is equal to z m by d square, and small n cancels each other. And here, after this, what's the remaining is z is equal to gravitational constant g, mass of the earth by d square. So this is what the expression for acceleration due to gravity, that is small g. So now we have derived the expression for acceleration due to gravity. So that is which is for an object under free fall, g is equal to gm by d square. M is this can be written as me, mass of the earth. Now what I will do is from this expression we will get two conclusions. See, what the expression is, z is equal to gme by d square. Already I have told you this is a constant. If I remove this constant and then the proportionality sign it will come. G is proportional to me by d square. The same can be written as in two ways. The acceleration due to gravity is directly proportional to mass, and acceleration due to gravity is inversely proportional to square of the distance. If we combine these two, again we will get g is proportional to m by d square, and remove this proportionality constant, then z is equal to gm by d square. Once again, the same expression we will get back. And now after this, if we substituted the value of these, what is the gravitational value and mass of the earth and d square, whatever the distance, if If we substitute these, then we will get the whatever the value of G. G is equal to, see students, already in my yesterday class I have taught you the value of the capital G is 6.7 into 10 to the power minus 11, and the mass of the earth is 6 into 10 to the power 24, and whatever the here the distance means here d, so d square means that is the radius of the earth, so that is to be taken into consideration. So that is, it becomes r square, and here 6.7 into 6 into 10 to the power minus 11 plus 24 from the law of exponents divided by r square, that is the radius of the earth, constant value it is 6.4 into 10 to the power 6 bracket square. And now after simplifying these values, simplifying this, see students, one more step I will write 6.7 into 6 into this 10 to the power 130 divided by 6.4 bracket square and 10 to the power 12. And next this becomes again 6.7 into 6 into 10 to the power 30 minus 12, law of exponents, divided by 6.4. And after solving this further simplification, the value of G, that is automatically 9.8 meter per second square we will get. This is how the value of small g is to be taken for an object under free fall. For an object under free fall, that is 9.8. And one more thing is, this value may change. It is said that in the physics, it is said that whatever the value of small g, 9.8 meter per second square, it is subjected to change. It may vary depending upon the places or the regions, from 9.0 to 10.0 meter per second square. This is just because of the geographical nature of the whatever our earth. It is said that our earth, the shape of the earth is not all exactly in the circular shape. It is in the shape of whatever that is. In the polar region, it is little bit bent, and in the equatorial region of the earth, it is little bit bulged. So this is because, and for this reason of the change in the shape of the earth, whatever the radius of the earth changes from the center of the earth, so whatever that radius value, here what I have written 6.4 into 10 to the power 6, this value changes depending upon this change in the radius. This also changes. Okay, and on this here whatever derivation I have taken today, I have derived today on this, a question of 5 marks, a long answer question will definitely comes in the examination. All of you please practice this derivation, and on this only the numericals will also comes in the exam. So this is a very important part in the whatever the gravitation lesson, and in the further class also the same things it will be continued. Okay, and this is the important part. Please be perfect, and up to this I will stop my today's class, and whatever the further part of this lesson I will continue in my next class. Thank you.